2020 Electrical Engineering Question 21. A single phase 4 kVA 200 bar 100 volt 50 Hz transformer with laminated CRGO steel core has rated no-load loss of 450 watt. When the high voltage winding is excited with 160 volt 40 Hz sinusoidal AC supply, the no-load losses are found to be 320 watt. When the high voltage winding of the same transformer is supplied from a 100 volt 25 Hz sinusoidal AC source, the no-load losses will be rounded off to 2 decimal places is dash watts. The NPTEL video reference for this particular question is Electrical Machines 1, Lecture 11 to 13 by Professor Tapas Kumar Bhattacharya, Department of Electrical Engineering, IIT Kharagpur. In order to solve this question, we must know what are the expressions for hysteresis loss, eddy current loss, and the core loss. The hysteresis loss is denoted by WH, which is equal to eta Bmax raised to x Fv, where eta is the Steinmetz coefficient, Bmax is the maximum permissible flux density, x is the Steinmetz exponent. It varies for different core material. Here, as CRGO steel is used as the core material, X is having a value of 1.6. F is the frequency of the supply. V is the volume of the core. Similarly, the eddy current loss is given by WE, which is equal to pi squared by 6 rho Bmax squared F squared T squared V squared, where rho is the resistivity of the core material, Bmax is the maximum permissible flux density in the core, F is the frequency of the supply, T is the lamination thickness, and V is the volume of the core. Now, the core loss PC is a sum of hysteresis loss and eddy current loss. When the transformer no-load test is carried out, we will get the no-load losses. This no-load losses can be approximated to the core loss. Similarly, if we want to separate the core loss into hysteresis loss and eddy current loss, we can test the transformer in different testing conditions. So here there are two typical test conditions. Case A, when the applied voltage to frequency ratio is held constant. That is, the Bmax term in the expression of WH and WE are constant. So we can write WH in a simplified form as WH is equal to A into F. Similarly, WE is equal to B into F squared, where A and B are constant and F is the frequency of operation. Now, case B is the condition in which the applied voltage to frequency ratio is not the same at every testing condition. Therefore, the Bmax term in the expression of WH and WE also varies in proportion to the V by F ratio. Therefore, WH can be simplified into WH equal to A V raised to X F raised to 1 minus X WE equal to B V squared, where A and B are different constants of proportionality. F is the frequency of operation, X is the Steinmetz exponent, and V is the applied voltage. And we are provided with 3 cases. Case 1, when the transformer is excited by 200 volt 50 Hz, the corresponding no-load losses can be approximated to the core losses PC, which is to be 450 watt. Case 2, when the transformer is excited by 160 volt 40 Hz, the corresponding no-load losses can be approximated to PC, which is 320 watt. Case 3, when the transformer is excited by 100 volt 25 Hz, we have to determine what PC is. So if you see case 1, case 2 and case 3, the ratio of applied voltage to frequency, that is 200 to 50, which is equal to 160 to 40, which is equal to 100 to 25. 100 to 25, which is equal to 4, which is a constant value. So the hysteresis loss WH is given by AF and the eddy current loss WE is given by BF squared. So case 1 PC, which is equal to 450 watt, now can be written as A into 50 plus B into 50 squared. Similarly, case 2 PC equal to 320 watt is written as A into the corresponding frequency, that is 40, plus B into 40 squared, which implies 50A plus 2500B equal to 450, and case 2 implies 40A plus 1600B equal to 320. Now it is like we have two equations and two unknowns. We need to solve for A and B. If you solve this, we will get the value of A to be 4 and B we will get as 1 by 10. B to be 1 by 10. Now we have to determine what is the core loss. We have to determine what is the value of PC for 100 volt 25 hertz. So that would be nothing but A into 25 plus B into 25 squared, which is nothing but 25 into 4 plus 625 into 1 by 10, which is equal to 100 plus 62.5, which is 162.5 watts. So 162.5 watts is the answer to this question.